guys, Bart from TST Industries here. Welcome to TST Garage. In this episode, we will be focusing on the installation of the Running Mate running light module that we've just produced. This unit enables you to connect a simple single circuit signal lamp to a bike and get running light functionality. In front of me, you see several different lamps that we produce and sell. We'll just pick one of these for our example installation. They're all exactly the same in how they operate. They do have a single circuit. This means only one set of lamps inside, therefore you have a positive and a ground. Now, if you want running lights from this type of a lamp and you only have one circuit inside, it's not really capable of doing that unless you add on a different circuit. This is why we make this. Our lamps, as well as many aftermarket lamps out there, are pretty standardized with the type of connection that they use. These are 3.5 millimeter bullet connectors. The male side is usually crimped on signals. Now, this is not an official industry standard, but through observation of other companies like ours and others have decided, hey, let's do it this way. This is pretty standard, why not? So for that purpose, we've outfitted the Running Mate with the female version of these connectors, and we also pin out to the same color code that is found on our signals. So no worries there, they just plug in, and then you have an input set of wires with three functions. You have a ground, a signal lead, and a running light lead. Now the electronics inside this capsule actually take care of knocking down the brightness of your light in running mode down to 80%. And then when you initiate your signals, they cut off the running light and go up to 100% for the blinking portion of signaling. Now this is very simple, you just couple it up, this is ready to plug in, but as you can see, we do have bullet connectors here, and most bikes have some other kind of OEM style plug. So for the different bikes out there, we do sell different types of harness converters, we call them. One side terminates in OEM style connection, the other side terminates in 3 conductors that we plug this into, and then we make that connection into the bike. So I just described a means of connection where you have a harness converter that plugs into the bike and then provides 3 outputs for this setup, and that's all good and well for the bikes that do have the running light circuit in the front signal lights. Now, what about the bikes that don't? Well, we're going to get into that. If for some reason you do have a bike that has the running light already in the bike and you're using the 3-to-3, we do have the video that we shot on that topic and that installation linked in the description of this video for your convenience. This episode here will only focus on the connection means for bikes that have a single circuit front signal. What does that mean? Again, you have only one type of light. There's no running light from the factory. Your bike only has a signal lamp in that location. So 2 wires is all you'll see, and typically the plug for these signals from the factory has only 2 wires in it as well. So for plug and play connection purposes, we do have all the different types of these harness converters for those types of bikes. But for those of you guys that want a running light feature on your signals now we'll need to get into how to connect that. And that gets a little bit more intricate than just plug and play, but we make it as simple as possible, and we'll show you in this video how to do that. Here on the table, I'll quickly demonstrate. Again, on the lamp side, you just have color code matching yellow to yellow, black to black. On the input side, you will match yellow to brown, and then black to red. And now you have your signal function hooked up, but you still have to hook up your running light. For that purpose, this kit, specific for the single circuit light bikes, comes with an extra auxiliary wire that is terminated in the appropriate connector to connect into our running light input on the Running Mate, and then we'll snip that off and seek out on the bike a switched positive 12 power source that does not turn off for some reason during riding. Like on some bikes, you'll have low beam headlight that is a constant 12, and on some bikes, when you go to high beam, that shuts down the low beam, and we can't have that, so we'll have to find something else. We chose the SV650 as a demonstration bike. This will be representative for any bike that has a 2-wire single circuit front signal. We'll just try our best to demonstrate it universally so that you guys can follow on any other bike. For this demonstration, I've allowed myself to take off the headlight off this bike because this is where all the wiring and connectors are. We've already mounted physically our signals. Here what you see are our echo signals with the red rings, really nice accent. Since the actual physical installation of the signals is not part of the focus of this episode, we've gone ahead and done that already. The wiring has to go around and come into this area here for this particular bike. Obviously this will differ slightly for other models, but this is where the connections are being made. So we'll get these wires in here and go ahead and start connecting some of the other components. We have our Suzuki specific harness converter here. Don't remember exactly which one's which. So what we're gonna do is just test it quickly. I'm gonna work with just the harness converter for now. Connect straight from the harness converter into our signal. Make sure contacts are insulated. All right, so I turned left signal and the light that I'm connecting is turning on. So left is gray and right is black for this particular bike. Okay. Since left is gray, let's start working with the left signal. Signal lamp connects to the 2-wire output from the Running Mate. Very simple, yellow to yellow, black to black. We do have these insulating caps that have a tendency to slide around quite a bit. So what I like to do is lock them down with electrical tape. I'll pull them over and then lock them down against the wire. I'll do one side and then I do a winding around both at the end here. This enables me to get a nice tightly wound package here. It also insulates against water, so that's a nice added bonus. All right, so the lamp side is already wired up. Now we have the input side, which has 3 wires. Here we go. We are doing the left one. We already have the left converter hooked up. We're gonna go yellow, which is the positive wire, to brown on the input side of Running Mate. Then the black from the harness will go into red on Running Mate. And quickly make sure the insulating caps are coupled and staying together. We're gonna test this real quick just to make sure we don't get too far before we tape everything down. And in fact, we're good here. And now it's just a matter of locking these down and connecting this to a positive 12 power source. Now this is where it gets a little bit tricky on these bikes because you have to find that power source. Okay, now this is looking proper. And now we have this plug available to us and also this plug. I'm not exactly sure what this is, but usually in these areas on bikes, we have an auxiliary power source that is switched and fused. Now, the first thing I like to do is test whether or not the running light circuit on the low beam actually switches off when you go to high beam. So first, I'll see in here. You can do that using a voltmeter, test light, or any 12 volt signal will do. So before you actually physically mount these, you can use the signals as your test light. So we have contacts in here. We could potentially touch them with our bullet connectors. We're going to do that. I am in low beam, and then it's just 3 conductors, so it's just a matter of matching up a pair that will work as a test light and just trying the different configurations of contacts here. There are 3 here, 2 here, so there's only a few that we can possibly experience. Just a matter of finding the one that actually exposes which one is my low beam. So for me, for this bike, negative is here, positive is here. Now it's just a matter of figuring out if this stays on when I go to high beam. And in fact, it does not. So that's a problem. We can't wire in here if we want to have running lights constant in high beam and low beam. So we need to find another place. So our main headlight connector's out, Hail Mary's here. If this doesn't work out, we got to go down on the chassis and find something else there. Shouldn't be that big of a problem. We have ample length in our connection kit, but like I said, typically manufacturers will provide some kind of auxiliary switched power here, and I'm pretty confident that this right here will work. I find it much more convenient to work with a voltmeter that has probes like this, so I'm going to demonstrate this version now. All right, let's see. We have, and there we go, 12 volts. Switches off with the ignition, switches on with the ignition. So we found where we're going to wire this into. Now it's just a matter of finding out which one's the positive, which one's the negative. Now from observation here, black with the white trace was negative, was ground. We have a black with negative here. That should be ground. I'm just going to test this really quick, make sure that I'm not getting it backwards, because electronics here will need the proper polarity. And in fact, yes, I found the positive. This is where we're gonna tap into. So now we can get an appropriate amount of length of wire here. Let's connect the running light connection kit wire to our running mate. Now we've taken up all 3 inputs, and let's see, how long do we need this thing? Well, I kind of like to leave all the wires similar length, so we're gonna get that much, snip it off, strip probably 1/4 inch, 6 to 7 millimeters off of the end, twist it. Our connection kit comes with 2 Posi-Tap connectors. For this particular installation, I'm just going to be using 1. I also see that the insulation sleeve on this wire, on this set of wires, is kind of close to the plug. So I'm going to open that up a little bit to gain a little bit more access for our Posi-Tap. And here we go. We have access now. I'm going to get our Posi-Tap, spin off the larger diameter. That exposes a threaded portion with a split in it. The split goes around the wire like so. We insert this cap over this wire, and then we will spin on and thread on the rest of this Posi-Tap. It does have a little piercing element here that goes through the insulation of the wire and makes our connection. All right. Now that connection should be made. The small diameter cap can come off, and this is where the other end of our running light connection kit wire goes into and connects to this whole mechanism. And as you can see, since the bike is still powered up, I already have running light here. This will change when we go to signaling. If you notice, it does get brighter, because running light operates at 80% of the full brightness and signaling operates at full 100%. When we reset it, it comes back into running light mode. So we have proof of concept on the left side. I'm just gonna repeat this on the right side of the bike. Then I'm gonna neaten up all the wires, make sure everything fits physically in here, and then we could return this bike to its previous state. All right, so here we come to having to make a choice. We either tap in 2 of these Posi-Taps, or we just make use of one with 2 wires in it. I'm sort of a fan of using the least amount of hardware possible. So I am gonna couple this up and leave my nice spare Posi-Tap for some other purpose. Get these guys spun together, make sure they still fit through the orifice in this little cap. Have to make sure that they protrude far enough so that they can actually be locked down. I don't think I like this. I'm actually going to extend these guys a little bit. Maybe go to about 8 millimeters of exposed wire. Now once I get a positive bite on this thread here and I get it spun down to bottom, give this a little tug, make sure it doesn't come apart. Test the system one more time. We have running lights, signal, signal, good to go. I'm gonna replace this because it is a sealed plug. We'll just put it back where it was. The location on this particular bike for this auxiliary power was up in here. So I'm gonna attempt to arrange it in the same way. Now this, at this point, goes a little bit beyond the scope of the instructional portion of this video. This is basically now a play of bulk distribution. Obviously, we do have a pretty bulky big old light that needs to fit in here, but it does have plenty of space on the sides. So what I would suggest is making sure this reaches and all our other wires are out of its way, and then S-fold these, make them into a nice tight package, and using zip ties, zip it down and then store it to the side away from any obstructions to the headlight. Now, like I said, that's out of the scope for what we were trying to accomplish here, and we're pretty much done.